From the Wi-Fi that's connecting you to this right now, to the very light that's letting you see your screen, our entire world is built on this invisible architecture of waves. So let's pull back the curtain on this hidden world and really see how it all works.
Okay, so let's start with something we all know, something we use every single day. Sending a message, information, through what seems like just empty space.
I mean, really think about it for a second. Your favorite song on the radio, a text message from a friend, a whole web page. How does that stuff just travel through the air to your device? It feels a lot like magic, doesn't it? But I promise you, it's all just physics.
To get our heads around this, we need to crack the code at the waves themselves. And it turns out, the secret isn't really the wave itself, but how we play with it, how we manipulate it.
So imagine a perfectly steady, predictable rhythm, just going on and on. That's what we call a carrier wave. It's this pure, kind of boring, constant wave that's broadcast at a very specific frequency. On its own, it doesn't carry any information at all. It's basically the blank piece of paper we're about to write on.
And right here, this is the key to everything. We take that boring old carrier wave and we start tweaking it in a super specific pattern. This process of tweaking or changing the wave has a name. It's called modulation. And that's exactly how we encode a message onto that blank slate. Now, here are the two classic ways you've already experienced this your whole life, AM and FM radio. With amplitude modulation, or AM, we change the height of that carrier wave. You can think of it like changing the wave's volume, up and down. With frequency modulation, or FM, we keep the height exactly the same, but instead we change the spacing between the wave peaks. We're messing with its frequency.
This is such a great way to picture it, especially for FM. Imagine you've got a slinky stretched out with a nice, steady rhythm. That's your carrier wave. Now, if you start compressing some parts and stretching out others, you're encoding information into the distance between those little wave peaks. That's frequency modulation in a nutshell.
So you see, it doesn't matter if it's the smooth curves of a human voice for an old-school analog radio broadcast or a super-fast series of tweaks that represent the ones and zeros of your Wi-Fi signal. The principle is exactly the same. We're just modulating a carrier wave to carry information.
Okay, so we figured out how to put a message on a wave. But that, my friends, is just the first step. This one simple idea unlocks an entire universe of invisible power.
Yeah, this same fundamental idea applies to so much more than just the radio in your car. We've really only been looking at one tiny slice of a much bigger picture.
And here it is, the electromagnetic spectrum. Now get this, radio waves, microwaves, infrared, the visible light our eyes can actually see, ultraviolet, X-rays, and even gamma rays, they are all the exact same thing. They're all electromagnetic radiation. The only difference between them is their frequency. And just look at how tiny that little slice of visible light is. Almost everything on this chart is completely invisible to us, and yet it is the fundamental toolkit of our modern world. It's wild.
And what's the one thing they all have in common? Well, in a vacuum, every single one of them travels at the same, absolutely mind-boggling speed, the speed of light. We're talking nearly 300 million meters per second. From the longest, laziest radio wave to the shortest, most energetic gamma ray, this is the universe's ultimate speed limit.
So now that we know about this whole hidden spectrum of waves, what can we actually do with them? I mean, how does all this invisible energy really shape our daily lives?
Well, let's start with an appliance you probably have sitting in your kitchen right now. Microwaves aren't just for sending messages, they're for cooking food.
So inside your microwave oven, there's this device called a magnetron, and it's blasting out microwaves. These waves are tuned to the perfect frequency to shake one specific molecule, water. As the little water molecules in your food start to vibrate back and forth billions of times per second, that friction creates a ton of heat, cooking your food from the inside out. Pretty clever, right?
Okay, now let's jump way up the spectrum to a much higher energy wave, the X-ray. While microwaves are great at vibrating molecules, X-rays have so much energy, they can just blast right through them.
You see, X-rays are a type of ionizing radiation, which is just a fancy way of saying they have enough punch to knock electrons right off of atoms. This power lets them zip through soft stuff like your skin and muscles, but they get stopped by denser materials like bone. And that simple difference is what lets us create those incredible shadow pictures of the inside of our own bodies.
And the applications go way beyond just waves. The fundamental force of electromagnetism itself, that deep connection between electricity and magnetism, powers some of our most amazing and advanced technology.
Just think about MRI machines. They use these ridiculously powerful electromagnets to create unbelievably detailed images of our bodies, all without any harmful radiation. Or what about induction stoves? They use a magnetic field to create electrical currents directly inside the metal of the pot, heating it up almost instantly. And then you've got maglev trains, which use massive opposing electromagnets to literally float above the track, letting them hit insane speeds. So let's bring all this home. We've really taken a journey through a world that is all around us, every second of every day, but is completely invisible to our senses.
We started with a pretty simple question about how a radio works, and that led us to discover modulation, the secret code hidden in a wave shape. From there, we pulled back the curtain on the entire electromagnetic spectrum, this vast, invisible landscape of power. And finally, we saw just a handful of the world-changing technologies that this spectrum makes possible.
So if there's one thing to take away from all of this, it's this. Everything comes down to frequency. A wave's frequency is its identity. It's what determines its energy, and that energy dictates whether it's a radio wave that carries music, a microwave that heats your dinner, visible light that lets you see, or an X-ray that sees right through you. It's what gives each and every wave its unique power to interact with and to shape our world.
From communication and medicine to transportation and cooking, this invisible spectrum is the absolute fundamental architecture of our modern age. Which really just leaves us with one incredibly exciting question. What are we going to build with it next?